Hello and welcome to screencast number 8. We're going to be looking at clean coal technologies in this screencast, and we're going to consider if we can capture and store carbon, since that is one of the leading problems with our greenhouse gases. And hopefully we'll get to what happens when oil spills pollute our oceans and our coasts. So those are the things that we're going to look at here today. So we can say that burning coal emits a variety of pollutants, unless there's some kind of pollution control measure that's in place. And I think we all know how dirty coal actually is. The composition of coal depends on where it was harvested, where it was taken out of the ground. And sometimes the coal can have impurities including sulfur and mercury and arsenic and trace metals. So some of those, as you read there, they're pretty scary because we know arsenic is toxic, it's poisonous. We know mercury can cause birth defects, and sulfur can cause respiratory problems. So these are certainly things that we do not want to see in our atmosphere. The United States tends to have a lot of sulfur in their coal because it's formed from marine sediments. And most of China even has more sulfur-rich coal from where it has been mined. When we look at coal-fired power plants, scientists and engineers are seeking ways to clean the coal of the sulfur and the mercury and other impurities, and this cleaning of the coal is referred to as clean coal technologies, where they produce technology and equipment and approaches that remove the chemical contaminants while generating electricity from coal. So this is where they're trying to move towards. There is an array of techniques that have been developed. There's various types of scrubbers and devices that can chemically convert or physically remove pollutants. Some of the scrubbers use minerals such as magnesium and sodium and calcium in their reactions to remove the sulfur dioxide, and that's what you usually see in the smokestack emissions. They can also use chemicals to strip away nitrogen oxides, which would be broken down into elemental nitrogen and water. And then there's the multi-layered filtering devices that are used to capture any tiny ash particles that are available as well. The clean coal approach, another clean coal approach that is done is drying the coal, because some coal actually has water in it. And we can actually gain more power from the coal if we have less pollution running through it, and this is a process that we refer to as gasification. This is where the coal is converted into a cleaner synthesis gas known as a syngas, and it reacts with oxygen and steam at high temperatures. And then we can integrate the gasification, which is just combining the cycle process, and the syngas from the coal is then used to turn a gas turbine and also used to heat the water and turn the steam turbine. So these are processes that we're using the energy of cleaning to run other things. The U.S. government and the coal industry has really invested billions of dollars in clean coal technologies for new power plants. They have helped to reduce air pollution from the sulfates and nitrogen oxides and mercury and that particulate matter that we mentioned. But there are still, there are still older coal industries that have not reached this technological advancement. And if they did, they would even be able to help reduce pollution even more. But there's a lot of money-fighting regulations and mandates on practices that are holding them back. And because of that, plants will continue to pollute our air for decades. energy analysts emphasize that these technologies make for cleaner coal, but will never result in energy production that is completely clean. And then they can go on to argue that coal is inherently dirty, and it's a dirty way of generating power and should be replaced outright by cleaner energy sources. Question then becomes, can we capture and store carbon? We know that carbon is a culprit to this climate change. So even if clean coal technologies were able to remove the last chemical contaminant from the power plant emissions, coal combustion is still going to release carbon dioxide into the air, and that will intensify the greenhouse gas effect. It'll worsen the global climate change as we know it. So there are many efforts now to carbon capture or carbon storage. Sequestration is the term that we use, carbon sequestration. And this is where you capture the carbon dioxide emissions and then convert it to a liquid and store it underground or in the ocean. So that all sounds like it's pretty good, where you could inject it then into the ground in geologically stable rock formations. So the carbon capture and storage, abbreviated CCS, is being attempted at a variety of new and retrofitted facilities. The world's first coal-fired power plant to approach zero emissions opened in 2008 in Germany. It's a Swedish-built plant that removes its sulfate pollutants, and it captures carbon dioxide. It then compresses that carbon dioxide into liquid form. It trucks it about 100 miles away and then injects it into about 3,000 feet underground into a depleted natural gas field. North Dakota and the Great Plains Synfuels plant gasifies its coal, and then it sends half of the carbon dioxide through a pipeline to Canada, where the Canadian oil company buys the gas to inject into an oil field to help pump out the remaining oil. So they use this as a pressure source. North Dakota plant also captures and isolates and sells 7 other types of gases for various purposes. So these are just a couple of the things that are being done. The U.S. Department of Energy is teaming up with 7 energy companies to build a prototype of a near zero emissions coal-fired power plant. It's going to cost about $1.3 billion, and it's called the Future Gen Project. And it's going to construct and operate a coal-burning power plant for electricity while capturing and storing carbon underground. This is located in Maradosia, Illinois, and it will pump carbon dioxide more than 3/4 of a mile underground beneath layers of impermeable rock. It's a showcase project. So if it succeeds, it will become the model for a new generation of power plants across the world. So as with everything, there's always another side of the coin. So let's take a look at this particular graphic. This is a carbon capture and storage scheme that is proposed to inject liquefied carbon dioxide emissions underground. The carbon dioxide may be injected into depleted fossil fuel deposits or deep saline aquifers or oil or gas deposits that are undergoing secondary extraction. So here we have our power plant that's emitting carbon dioxide, and if we're able to harness that carbon dioxide, we could take it and we could pump it into the deep saline aquifers. So these are saltwater aquifers. We could also put it into an abandoned coal seam to help fill up that coal seam. We would be able to put the carbon dioxide into the depleted oil and gas reservoirs from our fracking that goes on, and continue to put it down into those aquifers. So this is a possibility that could be done. Now, as I said, and we'll just go back and stay on this page. As I said, there's always a flip side to the coin for this, and the problem is we don't know whether we can ensure that carbon dioxide will stay underground once it's ejected there, or whether these attempts might trigger earthquakes. We don't know if the injections might in some cases contaminate groundwater supplies. And injecting the carbon dioxide into the ocean, could that further acidify the waters that are damaging our coral reefs? So the CCS is energy intensive. It will decrease the EROIs of the coal. So that's another thing to consider. It's going to add to the cost and the amount that we consume. And many renewable energy advocates fear that the CCS approach takes the burden off emitters and prolongs our dependence on fossil fuels rather than facilitating a shift to renewable fuel sources. So those are some problems that exist. So now we're going to look at oil spills and polluting the ocean and the coasts, and that we're going to go back and revisit what happened in 2010 with the BP's Deepwater Horizon off drilling accident that happened. Remember, we said 11 workers had been killed and oil gushed out of the broken pipe at a rate of the oil leaked at a rate of 62,000 barrels per day. The emergency shutoff systems had failed. The engineers tried one solution after another to stop the flow of oil and gas, which continued for 3 months, spilling roughly 4.9 million barrels. That's 206 million gallons of oil. The crisis proved difficult to control because we had never had to deal with a spill in that deep of water before. Offshore drilling presents very serious risks of environmental impact and may be difficult to address. The oil spill through the Gulf of Mexico washed ashore. The region suffered a wide array of impacts. Countless animals were killed. The birds were the biggest ones that had problems because they could not regulate their body temperature once their feathers had become coated with oil. Underwater nature of the BP spill meant that unknown numbers of fish and shrimp and corals and other marine animals were also killed, and it affected the coastal ocean ecosystem in complex ways where plants in the coastal marshes died, and this resulted in erosion of the marshes and put New Orleans at risk and coastal cities at greater risk for storm surges and flooding. The Gulf Coast fisheries, which supply much of the nation's seafood, were hit hard by the spill. Thousands of fishermen and shrimpers were put out of work. Beach tourism suffered, and there was an indirect economic and social impact that were expected to last for years. Here are some pictures that you can look at as we follow this. The Deep Horizon spill was the largest accidental oil spill in the world history. It eclipsed the spill from the Exxon Valdez tanker, which happened in 1989. And this is where oil from the Alaskan North Slopes piped to the port of Valdez through the Trans-Alaskan Pipeline caused long-term damage to ecosystems and economies in Alaska's Prince William Sound. When the tanker ran aground and 2.5 decades later, a layer of oil remained just inches below the sand in that region's beaches. So you can see some of the cleanup that's going on in this picture. Today, climate change melts the sea ice in the Arctic. It's opening up new shipping lanes. It's opening up these new shipping lanes. I'm just kind of watching my time there. I think we're going to have to stop here, and we'll talk about the Arctic ice in the next screencast. Have a good one.